So good afternoon, everyone. People are still flowing in. Welcome to the first session after the keynotes. This talk we're going to go over building REST APIs, how you can do this today and what changes are coming up. Some of you may probably notice that I'm not Andre. I'm Stefan Wittmann. Andre, unfortunately, is grounded in Florida, so I'm taking over for him. I'm the product manager for this part, so hopefully I still have some clue what I'm talking about. I lost my voice on Wednesday on the training session, so I'm still recovering, but I hope everybody can understand me well. If not, just raise your hand, let me know, and I'll try to do my best to make myself clear. Okay. I hope everyone had a good lunch. Good. Awesome. So the idea of this talk is to explore a little bit what REST actually is. Probably some of you already know that. Some of you maybe are just getting started with REST, so we're going to reiterate a little bit what REST exactly is, how you can build a REST interface in Cachet across our product suite, and then what changes are coming up in the InterSystems IS data platform according to what Paul mentioned earlier today during the keynotes. So that's roughly the outline. So first of all, this is something where people sometimes just get confused. They think REST is a standard, a protocol, or there are dozens of words for it. Probably REST is nothing of it. REST is more or less a convention. It is built upon HTTP protocol standards. So every time we talk about REST, we are basically talking about using and leveraging HTTP for very specific tasks. And this is what making or building, delivering REST services very difficult, because there is not a very coherent standard. It is a well-agreed best practice how you can build stuff out there, but it's not like one golden rule that everybody follows. This is what building REST interfaces makes difficult. The important part everybody should know and understand is that REST calls and REST designs are stateless, which means you're trying to not keep a state on the server between calls. That means if you find yourself in a situation where you say, before you're going to make this call, make sure you make this call first, because otherwise this call is getting screwed up, then you're probably doing something wrong, unless your first call is for authentication yourself. Okay, that's basically the only situation where it's allowed as a prerequisite that someone can use your system. Otherwise, you can make the calls in any order, usually. There are still some seats in the back or here in the front. So, I see there are people coming from the meetings. I just dropped out early. So this is the most important thing for you to remember. Never implement any state between calls. If you're doing this, technically you can do it, but you're just violating one of the core principles of REST. The idea why you do this is because it's making it easy and simple for you in the long run to A, build your service, expand services, and maintain them. On the other hand, on the client-consumer side, it makes it more easier for them to consume your APIs, because they just have to know the endpoints, they have to understand what they offer, but they don't have necessarily to understand the complete set of your API to make sure they know exactly when and how to call which method. So in general, it makes onboarding simpler, it makes maintaining your code base simpler. So in general, RESTful is based on HTTP, I guess that's clear. The most important thing for you to understand is from a security perspective, there's nothing special built into REST for security. So if you're coming from a web service world, there are web service security policies that you can embed into the payload to enforce a specific behavior. We don't have anything like this on the REST side, okay? Everything you get from security is leveraged by HTTP, so it's something like HTTPS, OAuth, it's basic authentication. All of these concepts you know from HTTP are just getting translated over to the REST world. There's nothing like a security policy. You have basically a couple of operations on how you can select specific tasks, how you execute things, and these are the HTTP methods that you can use. There are get, post, put, delete, and various others like head and options. We're just going to start, obviously, with the CRUD operations. You probably all at least have heard once. So you can create resources by doing a post method, saying you want to post a new resource. You can read resources by issuing a get. That's what you do every day when you use your browser usually. That's always a get request. You can put stuff if you want to update something, or you can use the delete method, obviously, if you want to delete something. There are more HTTP method keywords than just these, but these are the 4 most important ones, obviously. Okay. So if you want to know how to build REST stuff, then there are 2 key things you need to know. The difference between a URI and a URL. Usually you say a URI is something that specifies a path to a dedicated resource. This is usually what people refer to as a resource in the REST environment. They will tell you a URI is the path that points to a given resource, like a car or an order, an invoice. While a URL, a locator, points to a specific entity of this resource, like a very specific invoice, a very specific car. You see this in the sample. There are various ways how you can use a URL to identify a specific resource. You either use parameters like the question mark order num equals 1, 2, 3, 4, 5. This is less common. This is more the HTTP way of doing things because you're not messing with the path. Or you add another subpath, basically, to a URI, dedicating a specific resource. In this case, the 1, 2, 3, 4, 5 becomes part of the path, which is what's more common when you're building REST interfaces. But you can see both, and both are valid. This is already one example where I can see that there is not one golden rule for how you can build REST interfaces. There are plenty of options. And this is just one example. Wanted to point out, everybody who started with web services, there are a couple of differences. The first obvious difference is that REST calls are way more lightweight than web services. That comes because of the XML structure. XML always comes with a schema. It is fixed. It is not flexible. Which has advantages. You can make a binding contract between your client and your server. It's very easy to identify when something breaks. But on the other hand, you pay for this by a way more complex payload that you have to ship over the wire. REST usually uses and leverages JSON for the payload. It doesn't have to. You can also just ship XML or other things, or binary. But usually you do it with JSON. JSON is way more flexible, and if you can take a look here, it usually is way smaller, like in this example here. So we've had REST support in Cachet now for like several years. So you basically just subclass %csp.rest, and you implement a couple of rules saying, for each of these given URLs, I want to implement a specific logic. Let's say I have one URL /coffee. I want to route this URL for the HTTP method get to one method for the HTTP method post to another methods. And all of these methods basically implement the business logic to retrieve or update my coffee machines. And it's their responsibility to return the payload if there is some payload that you have to return. It's also their responsibility to generate a corresponding HTTP return code. So you have to say, is this a 200? Is this a 403? Is this a 505 because something horribly went wrong on my server, right? This is the responsibility of your method. There are two steps how you do this. In the management portal, you define a web application, so this is a dedicated web application. You REST enable it by setting the dispatch class to the class that you just implemented. You can set up authentication options for this, and usually you pass in a specific value for your timeout. So in case you are using CSP, Zen, or ZenMojo, one of the golden rules for you is that you have a dedicated CSP application for your REST stuff and a dedicated CSP application for your web application. So those two are separated. You can manage cookies if you want to in a consolidated way so that they share cookies, but the settings are separate. Okay. Then you go into Atelier. Basically, you implement your CSP dispatch class and start off. Okay. So I'm going to jump over this slide. So one of the issues we are facing today when you're building REST applications in Cachet or in Ensemble is that it doesn't come with a big toolbox. It's a very basic infrastructure for implementing REST services, but it's lacking a couple of important features. One of them just being proper automated documentation. So if you've built web services in the past in our system, we automatically generated a specific documentation for you. We generated a test page where you could see all the methods that are basically callable in this web service class, and you could interactively try them out. All of these features are not present in the current implementation of CSP REST. So the only thing you get is Documatic of that class, basically. And that's probably not what you want your developers to point to, right? So that's a huge issue. It's something that's missing. Second thing is, if you're building the documentation on your own because you want to have something for your developers, then that's usually decoupled from your implementation. Say then you start to implement a new method, a new REST endpoint, then you have to make sure in your process that you update the documentation that you just generated or that you built by hand. So this is something where we're definitely lacking something. In InterSystems Iris, this is exactly what we're trying to mitigate here. So there are a couple of things that we're doing to make your life easier. This all falls under the umbrella of API management. This is something you heard earlier today in Julie's talk. API management is a pretty huge field, a very hyped term in the industry, and it means dozens of things, depending to whom you talk to. But a couple of things that I would like to point out is that what API management means for us in the very beginning is making it easy for you to onboard new developers to your APIs. It means that you should be able to automatically document every API that you have on your system in a generic way so that systems and documentation are always synchronized and not out of sync. And it's important to make sure that different teams can work together, especially with REST services. You usually have one or two teams working together. The client-side team, the server-side team, they have different skill sets. They don't necessarily understand the back end or the front end, but both have to be able to say, this is the contract we're all agreeing on, and this is what the other side has to implement when we're making these changes. So what we are basically doing is we are allowing you to automatically generate a documentation from CSP.REST classes, such that you don't have to do these things on a manual way. And what we're doing with this is we're not doing something what we did with web services, right? In web services, we built our own stuff. We built an own page you could look at. What we're doing this time is we are integrating with the industry standard ways of documenting REST APIs. And there are, as always, a couple of those. One being Swagger, OpenAPI. There are others like RAML. This time we're going with what we identified as the industry leader, which is OpenAPI, which has Swagger under its umbrella. So we are generating a so-called Swagger specification file, which basically is a description of your complete REST endpoint. So you implement your CSP REST class, you hit a button, and we will generate this specification file, which details in the Swagger spec what endpoints do you have, which HTTP methods are valid for which endpoint, which HTTP return codes can it return, what is the payload, what's the description of this endpoint, what's the purpose of it, what's the authentication method that you can use or have to use in order to call this method, and so on. By itself, the specification file doesn't do anything, right? You can read through it, but obviously that's not how you're going to consume it. The Swagger community has lots of tools to leverage this specification. One is something which is called a Swagger editor, so you can copy-paste that specification into the editor. You can edit the specification, add more information like descriptive text, or you can add HTTP return codes, for example. It has something which is called Swagger UI. That is basically an interactive representation of the specification file. So you can render this in your browser, go over it, click on the endpoints, see what they do. You can try them out by pressing a button, filling in the arguments, and see what they actually do. So there's a complete ecosystem how you can work with the Swagger file. So this is basically divided into multiple phases. What I just described is something what we call phase 1, which will be part of the first release that Simon and Paul mentioned earlier today as GA January 2018. So this is something you can expect then or now if you enroll for the early adapter. The idea here is you already might have REST endpoints defined on your system. So you don't have to rewrite anything. You can leverage what you already have. You get additional capability by basically generating the Swagger files and then leverage the Swagger tools that are available in the community. What is missing in this step yet is a way to enrich this Swagger specification by additional data that you might have. So we're trying to extract everything that you already have in your CSP REST implementation. Like, for example, if you have a method that's getting called and you have a descriptive documentation text above that method, we will extract it and put it into the Swagger specification route for this dedicated path. But there are things we can't extract, like we don't know which HTTP return codes your method is returning, right? You might be calling other methods. Some methods are just calling macros, which return HTTP codes. So we just have no way to realistically introspect your code and know which HTTP return codes you're returning. So what we generate is that every method basically returns an HTTP code 200, because we can assume that that makes sense, right? But we don't make any assumptions about other HTTP return codes, okay? So if you want to enhance basically the specification and say, okay, I know this method returns a 200 and a 403, then you as of this phase, have to manually go into the Swagger specification file that we generated and enhance it, right? The issue with this approach, obviously, is if I edit this generated file and I regenerate it, then I have to do all the work and merge information, right? So this is not the best way of dealing with this, which is, skipping over this, why we're going to talk about phase 2 as well, which I'm going to show you in the demo in a minute. But this is not part of the general release in January. So what we're doing there is we don't want to tie ourselves just into Swagger, because maybe Swagger is gone in 5 years. You never know in this industry if a standard is really going to survive for so many years. You just don't know that, right? Especially in this arena, we have like 5, 6 dedicated standards. They all have their community. I personally think Swagger has by far the largest, so I think it's a good pick. So what we do internally is we don't directly generate Swagger, but what we do is we generate an internal model, which we call the REST specification, the REST spec model. And from this model, then we generate a specification like Swagger, or maybe in the future something else like RAML, right? So we are decoupling ourselves from one specific support for a standard. This REST spec then can be persisted in your system, and you can manually edit this REST specification and enhance specific information like the HTTP return codes. You can specify the payload and various other things. That means if you change your endpoints then, we will merge this automatically for you into the REST specification so you're not losing any changes. Okay, so personally, I think phase 2 is the real thing everybody should probably hope to get their hands on. Phase 1 is more or less just giving you a good starting point. But it's not the good starting point if you want to build an API and do iterative changes on your endpoints and keep the documentation up to date, because it's just not ready for that yet. So phase 2 is what I think is going to help everyone out here. Phase 3, to add a little bit on this is where I think the real value comes in, is we actually don't want you to implement your code in CSP REST any longer. What we really want you to do is specify what your API endpoints look like. Either you do this in the REST spec, or you do it in Swagger, or whatever tools you like. And this becomes your single source of truth. And then you say, okay, I've described how my REST points look like. I click a button, and then we automatically generate the complete endpoint for you. Given specific best practices, we're going to automatically dispatch to the methods, which include your business logic, so we can keep the generated code and the implementation of the endpoint separate. And this makes it interesting because multiple teams can work on the same specification. The front-end team can work on the Swagger specification. That's what they know. Your back-end people can work on the Swagger specification and maybe the REST specification internally, because that's what they both know, right? And you can work on this on the same model with different tools and making sure it's always synchronized and in sync. The other good news when we're doing this is that we can take a lot of the work and a lot of the burden of the day-to-day jobs you have to do as a developer from you, like implementing standard HTTP return codes, like what happens if someone is trying to access a resource but he's not authorized to access it, right? There's a dedicated HTTP return code for that. We can make that check for you and automatically return the corresponding HTTP code for you, making sure it's consistent across all the implementations, across all your endpoints, okay? This is something you have to do manually today, so maybe you do it for method 1 and 2, and you forget to do it for method 3, right? And your endpoint is inconsistent, okay? Just describe it once in your specification, generate everything, and then it's consistent, and in sync with the documentation. So I think phase 3 is really where the added value is going to get in. So let's take a look at what this actually looks like, hopefully. So this is my virtual machine here. I'm running InterSystems Iris on it, one of the earlier builds. What you see here is Postman, which is a UI client for REST interfaces, basically. One of the new things you will realize when you start it up is that we added a couple of REST endpoints for you to start discovering all your APIs. So that's one of the first things we had to do. We gave you a new endpoint, which is called API/management. So this includes everything that's related to the session, basically. You can say, give me for the samples namespace all the CSP-enabled REST interfaces. So if I run this, I get back an answer from the system. Start here. It's basically an array of all the enabled CSP applications which dispatch to a CSP REST class. Okay, so I see all the system APIs /API deepc, I see /API atelier, I see /API docdb, /API ino, and so on. I see from which namespace do they originate from. This system here is pretty much empty, so I haven't defined any user REST applications. So you only see the system ones that we ship. When I add my own applications, they're going to show up here automatically. I don't have to do anything for that. What you also will see is that every one of them has a link to the so-called Swagger spec file. This is the Swagger specification we generated for this endpoint. So let's say I click on the one for I know. Because this is relative, it will automatically update my request here. I send it. And now I get a full-blown, here we go, Swagger specification for all the I know endpoints. You can see this thing is huge, like, yay, 2,600 lines. And it's completely generated. So this is nothing one in learning services put together. It is just pulling out all the information from the classes that specify the I know endpoints. It's putting out the descriptions from the class methods that we're calling. So at least this is a good starting point. I can take this, copy paste it, let's say into a new file. Here we go. And there's one thing you should notice is it always gives you a so-called host information at the very bottom here, at the very top, which is the server it originated from. This is important if you want to use the test capabilities, the interactive capabilities of the Swagger tools. So it knows exactly where's your server and where do I have to call if I want to execute one of these endpoints. So make sure that these host informations are up to date. If you're generating it from one system, but in reality that system is running somewhere else, make sure that you update this information and make sure that it's actually an IP address that's accessible from outside systems. In case my environment here, this is now a path which is not resolvable outside of my virtual machine. So I would have to go in here and actually add an IP address that's resolvable on my Mac if I want to use it. Okay, I've done this already in another file. This is just the Swagger specification for docdb. It's not as huge, but still something. And now I can go over here. Starting off a container with the complete Swagger tool. In this case, this is just the Swagger UI stuff. I'm running it on my local machine on port 80. pointing it to my, where is it? Swagger docdb JSON file. So, here we go. Let's go to localhost. And there we go. This container now runs the Swagger UI tools. I'm not going to open up in the browser right now because the internet is broken for my machine here, but this is what it basically looks like. It's pointing to my local file, swagger.docdb.json. I could point it to another file if I wanted to. And it lists basically all the endpoints that are accessible on this machine. So I see this is a GET request. The path next to the base path is .v1 slash namespace. You can see that the namespace here is an argument, which I can supply. So if I click on tryout, it will give me an argument list, which has exactly one argument for the namespace. I can fill that in, click on execute, it will automatically run it, and come back with the result. Right? Not sure if this works. Maybe let's check it. Yeah, it does. Okay, so the response came back. It's empty in this case for this endpoint, so that's okay. I was just checking if it works because the IPs sometimes get reassigned from the VM. So, but this actually works okay. So you can say here, do you want to have application/JSON, application/XML, depending on what the endpoint supports. These are all the kinds of information that get generated in the Swagger specification, right? So your server can say this endpoint supports XML and JSON, and another one maybe supports just JSON, right? You can see this is not a PUD yet. So some of these methods, for example, have information. Some of them have no method description at all, so it's completely empty, and you just don't know what these endpoints do, right? So the next task, obviously, would be to either enhance your implementation and say, okay, now I go into my CSP REST classes that I implemented and add documentation. Or you go off and say, let's take a look at the REST specification that I just talked about and enhance this. Not going back into my CSP REST class, but I directly go into the REST specification and update that. So let's take a look at how this looks like. I have it open here. So let's reload. One word about this. This is obviously not productized yet, so this page looks absolutely ugly. Don't judge it. But it hopefully gives you an idea of what's happening behind the scenes when I'm talking about this REST specification. So I get a drop-down box on this side. I can see, okay, these are all the REST applications that are enabled on the server. Let's, for example, pick DeepSea. And then it will basically give me similar information than what you just saw on the Swagger specification. That's pretty obvious because we have to capture very similar information. We have to know which endpoints are there, which methods, HTTP methods are supported, what are the response codes, right? It's more or less all the same. But you see, it's a little bit separated into multiple areas. So I have something like a data section, I have something like an info section. That's something we didn't have before in the Swagger specification, right? Swagger specifications just said default, and here are all my paths, right? On this environment with the REST specification, we do one thing. If your REST implementation is just one monolithic class, then you won't see this section. But if your REST implementation is using forwarding rules to modularize your implementation, you say, okay, for slash, what do we have here, slash data, slash something, the implementation goes off into this CSP REST class. And for slash info slash something, we go off somewhere else. Then we break them down automatically into modules and say, this module is dealing with data, this module is dealing with info in this case. And later on, we can break this out into multiple Swagger specifications if you want to. Because sometimes it makes sense to say, a dedicated team only works on a specific subpart of my API, not on everything. So you may want to generate sub-specifications and not the complete thing. If you're taking a look at the specification that HealthShare is generating these days, it's massive, right? They have one base path with thousands of endpoints, literally. So if you generate this thing, it's over 100,000 lines of code. Right? Nobody is going to work in this thing, right? But they're making use of the forwarding rules so we can separate it out into multiple sub-specifications and then dedicate specific teams to one of these modules. Okay? So depending on the size of your system, that makes sense. So if I go down into something, you will see a very similar interface. I can select the post for the MDX execute. You can see the parameters, you get the responses. I can try it out. It's more or less very similar to what you know from the Swagger specification. The more important part now becomes we have the same thing again in edit mode. So now here I can go into the post for MDX execute and take a look at the response objects. I see, okay, there's a response status 200 associated with it. That means that we return HTTP code 200 for a specific situation. I could add more response codes to this and say, okay, we also return a 403 under these circumstances, save it, and then regenerate my documentation, which we just saw on the other tab, basically. So if we go in here and let's say the descriptive version for release version 1, that's what we see here, right? This is just a text. I say this is release version 10 now. I save it and reload. Awesome. And I broke my system. So this is what happens when you try to set it up like 1 hour before you do your presentation. Okay. So what happened yesterday was obviously that it saved it. Trying to go to fix it after the session, okay? But the idea is you will get an editor for the complete REST specification, can edit stuff, save it, and when you change your implementation, we will merge any changes that you might have made in your system back into the REST specification. Then you can generate your Swagger specification, for example, or later on something else like RAML, and share it with your documentation team. You can share it with your client implementation team. The nice thing about it is Swagger, for example, comes with client tools, which can consume the Swagger specification, and then they can generate a client for different languages, like for JavaScript, they can generate it for Java, Node, .NET, whatever your environment is. So they generate client code which allows you to call all of these endpoints, and you can directly call these methods. You add something on the server, you regenerate the Swagger specification, you regenerate your .NET client, and everything is in sync. You don't have to re-implement any code at all. That's a very nice tool chain. The other thing you can do is you can generate unit tests as well for your REST endpoints. That means you can generate a unit test for your endpoints in, let's say, Node or something else. Just run it and make sure that nothing breaks and that your REST endpoints actually do what you documented them to do. As everything is generated, obviously, these unit tests should never fail, but nevertheless, it's not a bad idea to have that, right? So that's basically the idea where we're going into. We want to make it sure that you don't have to do any manual steps in your REST implementation. We want to automate as much as possible for you to make sure that the specification, the documentation, and the implementation are always in sync and usable for multiple teams with different skill sets, like front-end developers, back-end developers, right? That's the idea where we had it. I think that's everything I have so far for the demo. Any questions on that? Yeah.
Does InterSystems that class as well, or does it?
No, it only goes into everything that's related to the CSP REST classes. So if you have forward rules in your CSP REST implementations, we will follow that and make sure we gather all the endpoints, but we won't introspect your code, the business logic.
So we could potentially take existing REST services on older versions of HealthShare and port them into a new version of HealthShare or Iris, generate the spec docs, and that can kind of buy us time before we upgrade. We have a lot of clients that want the Swagger docs, so that would be a tool that we could use as like a bridge to buy us time.
Yeah, absolutely. You can find me later on. I haven't said this in this conversation here, but the tooling that I've showed you is version independent, which means if you need it today for very specific reasons, we can talk about giving you an ad hoc to run it on the version that you already have, just to generate the specification. Yeah. Yeah.
Whatever you have showed basically is whatever you have showed basically is concerned about the creation of the REST API. But what about maintenance and the performance of the REST API? Is any new tool you are introducing which will basically help us to see how the REST API is working currently?
Yeah, so one of the things that I've shown you here is that we added new APIs to introspect all the REST APIs that are live on the system. One of the things that we want to add, but that's definitely not GA January, that's afterwards, is going to add metrics on which APIs are getting called how often, which APIs are getting called by which developer roles, so that you can see who is using which parts of your APIs. I think that's it, at least in the short term, what we want to do. In the long term, there are more things that we would like to do, like enabling throttling and other topics, but that's definitely more long term. Yeah. So I think we're running out of time, but if you're interested in this, make sure you go to the Tech Exchange. The main developer for this is Steve Morrison. Obviously, talk to me, Andre Cerri, and to the product manager, which is me. So just go find us at the Tech Exchange. We're happy to show you a demo of what we have, maybe even a working demo. No, not sure. Don't making any promises. And enjoy the conference. Thank you very much.